Hello everyone, I'm Fei Liu from City University of Hong Kong, and we're going to share with you our recent work on evolution of heuristics towards efficient automatic algorithm design using large language model. We know that algorithms are important, and the design algorithms usually requires expert knowledge and a long trial and error process with intensive manpower. For companies, there are many long tail problems exist. So if they want to design one algorithm for a problem, it becomes very costly. Therefore, automatic algorithm design has been a long-standing pursuit for both academics and industry. Hyperparameter tuning is a hot automatic algorithm design topic. Many existing algorithms can be used for hyperparameter tuning. However, we still require an existing algorithm framework exists, and then we tune the parameters rather than designing new algorithms. Genetic programming is another approach. It has good flexibility and an intuitive approach towards automatic algorithm design. However, we still require to handcraft the basic algorithmic components as well as the search rules for genetic programming. So in the area of large language models, we have observed that the increasing power for reasoning and coding capabilities of large language models. Moreover, we also have developed some advanced prompting techniques such as chain of thoughts to increase the ability of large language models in solving complex tasks. So we may wondering that are those increasing powerful large language models and advanced prompting techniques sufficient for automatic algorithm design? So currently, our answer is no. Here, we compared large language models to prompt standalone large language models and large language models plus some search on solving algorithm design tasks for 3 problems. And we find that merely allowing a large language model to attempt multiple times is not enough. However, when we compare buying large language models with some search, it can significantly enhance the overall performance on algorithm design. For example, here we only use 500 queries to large language models. When it has some search framework used, it outperforms the 10,000 standalone prompting large language models to design algorithm. And among different search methods, evolutionary algorithm is a highly effective option. And when we want to search in the heuristic or algorithm space, which is non-differentiable. So before we dive into the evolution of heuristic, we first introduce evolution of code. And here, each code is a code implementation of an algorithm. When we start with an initial population which consists of several codes, and it goes through an evolutionary process. In each evolutionary process, we select some parent codes and we do reproduction to generate new code. We evaluate code and we add code to population to update the population. This evolutionary process will repeat many times until finally we got a final population with possibly a best code for the target problem. And in the reproduction, we can, for example, we generate we prompt large language models to generate new algorithms of code of algorithm inspired by the two given codes. And this evolutionary of codes way is used in our preliminary work of EoH and as well as the fun search from DeepMind. Evolution of codes is effective, but when we think of how human design algorithms, we find that we will usually do some reasoning over existing ideas, and we find a good idea, then we implement the code for this good idea or thought. Therefore, in evolution of heuristics, we propose to evolution both the thoughts and codes to mimic the algorithm development process by human. And we also developed some instruction strategies or prompt strategies for the better exploration, better search the heuristic space. For example, in the right-hand side, we have three existing heuristics, the source and their codes. We will prompt large language models to do reasoning over existing heuristics, find some key components and design a new heuristic. Then we implement the code for the heuristic, and possibly it will generate a new heuristic with better fitness. So here, the major difference between our evolution of heuristic and the preliminary evolution of codes is that we evolution on both thoughts and codes, which is we believe is better for algorithm development. And then we will demonstrate evolution of heuristic on three combinatorial optimization problems. The first one is online beam hacking problem. We are in this problem, we're given a set of items and a set of bins. We want to pack items into bins to minimize the net use number of bins. We compared heuristics designed by EoH and the human design heuristics, as well as for the heuristic from search. We find that the heuristic generated by EoH performs best on different distributions. And we want to note that the heuristic only designed with 2,000 queries to large language models in 30 minutes in our personal computer, which make the algorithm design accessible to ordinary researchers and people. The second problem is traveling salesperson problem, which aiming at find a shortest route that visits each node once and return to origin node. And we compared the heuristic designed by EoH to the human craft one, as well as the Google R tools and some recently developed neural solvers. We find that the results are quite promising, as the heuristic designed by EoH achieves zero gap on 3 of the 6 instances, and also achieves the best performance on rest of the instances. The last problem is flow shop scheduling problem. We have n jobs and m machines. We want to schedule the n job on m machines to minimize the total schedule length, which is the makespan. And we also compared heuristic designed by EoH to the human designed ones, and also the neural solvers. The results are good as well, and here's the algorithm designed by EoH generates the best performance on different distributions. In this slides, we want to illustrate how the heuristics are evolved during the algorithm development process of EoH, and we find that the new ideas and the new code pieces are introduced during the evolution process, and finally we got a heuristic with and its code consists of several hybrid functions that are not intuitive to human experts, and it performs best. We can see that it is more complicated than others, and it performs best on the target problem. So to conclusion, in this paper, we introduced evolution of heuristic, and we believe that it will become a new paradigm for algorithm design. When we compared it to the conventional human-crafted way and the deep learning approach, we find that EoH requires no model training, and also it only uses minimized hand crafting. Moreover, the EoH is an open-ended heuristic development process. When we give more budget, we can further improve the performance of heuristics. And finally, it also enjoys good automation, and also we find the promising results on many problems. So as a general paradigm, we have not only demonstrated them on combinatorial optimization problems, we have also successfully applied these techniques on many algorithm design tasks. For example, we let it to design the adversary attack methods in image adversary attack, and we let it to design the acquisition function in base optimization and big human crafted one. And we believe that it can be further in the future be used in many other tasks. We have also open sourced our code platform, and if you are interested, you can propose and test your own heuristic search method in the platform, and you can apply it on your own application scenario to discover some interesting and promising heuristics that never be designed by a human expert. Okay, if you are interested in your work and you want to know more details, you can scan the code to get a paper and get a code. And also, if you are interested, you can contact us through the email. Thank you.